We, as journalists, have to stop treating AI as a tech gadget. We need to look at AI from an investigative standpoint and hold it and the interest behind it accountable. It's been years now that I feel trapped in an AI hype train. The level of hype seems not to be ending. The discourse around AI takes either the form of, oh no, we are all doomed, or only with AI can we cure cancer. But behind both narratives are hiding the same people, the same companies, and the same interests. I certainly feel like I'm treated with a stick and a carrot. I often hear the phrase, AI is a black box. We say this, throw our hands up in the air and walk away. But we can do better. We need to do better, not only if we want to learn about these technologies, but also if we want to hold AI systems and the companies behind them accountable for their impacts on the world. When we focus our investigative lens on AI, we realize that the Sam Altmans of the world are overselling AI. In fact, they hyped it up so much that the only problem they could ever imagine was that AI was killing us. But the real problem, it turns out, is that AI is unreliable and repeatedly wrong. The real issue here is not that AI is smarter than us, but that we think it is smarter than it is. I propose dataset investigation as a method to holistically interrogate AI systems, the data, the models, and the effects. AI models are indeed non-deterministic and unexplainable. It is difficult to understand why an AI system returns the result it does, often even for experts. Data that is used to train these AI systems has an oversized influence on the results of these AI systems. And if we look closer at the datasets used to train these incredibly complex machines, we recognize the models, the power, and learn about the emerging effects of algorithmic systems. Since we don't understand how models really work, it is only by looking at datasets that we get a better sense of how AI models work and the gaps, errors, and biases that can emerge. Take one popular dataset, for example, Lion5B, an open source dataset of images and text captions scraped from the internet. It is designed for large generative models and was released in 2022 by Lion, a German non-profit organization. The dataset contains 5.8 billion images used to train machines how to interpret the world. These are a lot of images. If your full-time, 8 hours a day, 5 days a week job were to look at each image in the dataset for just 1 second, it would take you 781 years. Training a model on Lion5B is meant to give it a comprehensive representation of the world and build a vocabulary of things and concepts. For decades, datasets have been constructed using human intervention. This generally yielded datasets of high quality, but too small to make today's AI yield any meaningful results. The goal of the project to create Lion5B was to find ways to curate datasets on the scale required by this new type of AI system. Specifically, its authors wanted to create an image training set with purely automated methods, with no humans in the mix. On the homepage, its creators explicitly warn against its use in real-world context. This warning has been largely ignored. Lion5B can be found in many, perhaps hundreds, generative AI systems. As I said, Lion5B scrapes images from the internet. Lion devised a process for selecting images from these websites. On the surface, this sounds very harmless and obvious, but the details do matter here. From this large corpus of billions of websites, we can notice that some of these websites, in particular, are very well represented in Lion5B. There are nearly 155 million image-text pairs from Pinterest, about 1 in every 40 pairs. 2.4% of Lion5B, 140 million image pairs, comes from Shopify. This number is even higher, 5.8%, if we only look at the English language part of Lion5B. 72 million pairs are from Slide Player, a platform for storing and sharing PowerPoint presentations. One reason these websites are very well represented in Lion5B is because they contain a lot of images. But on top of that, content from these 3 sites is served up in a way that makes it particularly appealing to Lion's method of statistical curation. All 3 sites serve images optimized for Google Search and its PageRank algorithm. Image captions should describe what is in the image. However, most captions describe what the site's owners want algorithms to see, not what they want humans to see. Line 5b contains less about how humans see the world than it does about how search engines see the world. It is a dataset that is powerfully shaped by the commercial logic of today's web. This is what we call a structural bias, a bias that can emerge from the way a dataset is put together and from the ecosystem around it. An ongoing problem is that curation by statistics amplifies many of those structural biases. Structural bias is just one element that dataset investigation can uncover. It also allows us to identify other forms of bias. We usually think of Line 5b as a singular entity, just one gigantic training dataset. However, it actually consists of three distinct parts, separated by language. To make these subsets, Line developers again relied on a machine learning model developed by Google to classify the language of the captions into one of 107 language classes. The first set only contains English captions. The second set contains captions in all other languages. And the third set contains captions in which the language couldn't be reliably identified. English is by far the most common language in the set, followed by Russian. French follows Russian and then German. The dataset contains over 2 billion images labeled as English. This amount of images means that every English speaker is represented by almost 2 images in the dataset. There is a similar situation for other European languages. However, only very few languages reach that level of representation. For example, Burmese is underrepresented by a factor of 1400, and Amharic even by a factor of 3500. This means that for every 3,500 Amharic speakers, there's just one image caption labeled as Amharic. We look at this and it is what we would expect. It is a form of bias that we learn to expect in data. Data is always biased. It is an inherent attribute of data itself. But I want to make a different point here. Interestingly enough, these statistics tell us less about the composition of the internet where Line 5b sources its images than they do about the shortcomings of the language detection model the Line 5b developers chose to use. To give a stark example, there are more than 34 million text captions in Line 5b that Google's language detector has classified as Luxembourgian, a language that is spoken by a mere 300,000 people. This is 114 captions for every speaker of that language. When we actually look at a set of supposedly Luxembourgian image pairs, we can quickly see that the caption is mostly English or in a different language altogether. The AI system used to construct Line 5b is failing quite spectacularly, and not just for Luxembourgian. It offers a particularly clear example of how Lion's hands-off processes fail. It is the result of statistical curation, a belief that these systems are infallible, and simply accepting the results at face value. Looking at the languages tells us something specific about the worldview Line 5b perpetuates. It is a worldview that focuses on the English-speaking and European world. It is a perspective that is carried into AI models that are trained on it. For models trained on Line 5b, English and English-speaking culture is valued more than the other 107 languages combined. There's one thing in particular that Lion gets right. They publish the datasets as open source. In the field of AI, they're one of the very few in doing so. It is what allowed us to dissect Line 5b in the first place. Openness in the AI field matters not just for model biases, but for the structural biases in the ecosystem. Advocating for dataset transparency is so important if AI systems are ever going to be accountable for the impacts in the world. Dataset investigation is one of the few tools we have available to gain insight and understanding into the most complex systems ever conceived by humans.